Hi, welcome back to my channel, and again my name is Mark, and today we'll be discussing about a mathematical expression. So something we can write like 3x plus 5y minus 2, that's actually a mathematical expression. So those x and y are variables that are used to represent certain things. So for a certain mathematical expression, let's say 3x plus 2y plus 5. These two are the so-called variables. These are constant. So for a mathematical expression that is composed of only one term, by the way, in this expression here, there are three terms. Specifically, this is one term, this is another term, this is another term, which means that a certain expression and another certain expression is being separated by an operation either plus or minus sign. So this is another term, this is another term, this is another term. So for a certain mathematical expression that is composed of only one term, let's say 5x, let's say x or y, or and so on. So that's actually a monomial. A certain mathematical expression that is composed of two terms, let's say 3x plus 2, that's actually a binomial. So again, for one term, that's a monomial. And for two terms, that's a binomial. So we can say that for three terms that are trinomial and so on. So actually, to generalize on that, an expression that is composed of two or more terms is called a polynomial. That's it. Okay, there is this certain thing, a definition, in which we have to pay heed to in order for us to master the concept of mathematical expression. So let's consider this definition here. Mm, for every n element of natural number, which means for every a natural number n and any number a, number a. So when I say a natural number n and any number a refers to be a real number. So a to the n is equivalent to a times a times a times a, which are composed of n number of a's. So it's n number of a's. Okay, and another definition is the zero power of a, provided your a is not 0, is 1. So when we say the zero power, so which means this is actually a power and this is actually a base. And the negative power of a is a to the negative n, where n is again a natural number, is this. So which means if you have a certain number, let's say 5 raised to a negative power, let's say negative 3, you can write 5 to the negative 3 as 1 over 5 to the 3. So which means you take the reciprocal of this term and change your exponent to a positive sign. That's it. So again, we have the to remember certain a very specific detail in studying mathematical expression in order for us to, of course, master the concept and for us to avoid mistake. So let's say, for example, you have these 3x plus 5. Again, these are all base. These 3 is actually what we call coefficient, which means this coefficient is actually a constant to this variable x. This thing is the entire base. And if you raise this thing to, let's say, 3x to the 5, then this 5 is the exponent, or what we call the power. Okay, so this time we'll be discussing about the addition of mathematical expression. So when I say addition of mathematical expression, what I mean is addition or could be a subtraction, because these two operations are actually the same. Subtraction is actually the additive inverse of addition. So with addition as the additive inverse of subtraction. Okay, so there are things that we have to remember when we add mathematical expression. First is number one, when we add terms of the expression, we have to make sure that they are the same. So when I say the same, they have exactly the same variable and same exponent regardless of the coefficient. So example, 3x and 8x, x squared, 4x squared. So these have the same variable, the same exponent, and the same x, the same exponent. So you can add these. Same with these. You can add x squared and the 4x squared because they have the same variable and the same exponent, regardless of their coefficient. So example, this is the coefficient, this is the coefficient. So regardless of this coefficient, you can add them because they have the same variable and the same exponent. Okay, number two. By adding terms, you just have to copy the variable and the exponent, or I mean, you have to copy the term and add the certain coefficient. So example, you have 3x and 8x. So you just have to copy this term x and you have to add the coefficient. So you get 11x. That's it. Okay, third rule. You have to look into the signs of those terms that you have to add. If they have the same sign, either positive or negative, you just have to add a coefficient and copy the common sign. If they have different signs, let's say one is positive, the other one is negative, so you have to subtract the coefficients and copy the sign of the larger coefficient. Okay, for example, you have 3x and 8x. So let's say this is positive plus 8x, which is also a positive number. So you just have, by second rule I mentioned earlier, you have to copy the sign. So you have to copy the sign and you have to add the coefficient. Why I add a coefficient? Because they have the same sign. Positive and positive, so you get 11x. Another example, you'll have 4x negative 4x plus 3x. So you have to copy the term, which is the x, and because this is negative, this is positive, so you have to subtract the coefficient. So 4 minus 3, you get 1, and copy the sign of the higher value. So this 4 is larger than 3, so you have to copy the sign of 4, which is negative. So you can have negative 1x. Or if your coefficient is 1, you don't need to put 1 here. Any variable that you cannot see any coefficient attached to it, which that's understood as 1 as the coefficient. That's it. Okay, so let's consider this example here. So it's actually addition of polynomials. So how do we add these terms? I mean this expression and this expression here. So again, let's apply those rules. Number one again, you have to check if they have the same variables. I mean, these have the same terms. So when we say that, you have to check the variable and the exponent regardless of the coefficient. Next is, again, you can add the coefficient if they have the same sign, or otherwise you have to subtract. And when you subtract, you have to follow the sign of the larger value coefficient. So let's say this one. So you have to, if you have to add these terms, you have to check if there is another x cubed here. No, so you just have to copy that. 3x cubed. For x squared, you have x squared here. So they have the same sign. So you just have to copy the variable. So that's x squared. Since they have the same sign, so you have to add the coefficient to get 4. This one you have to check they have the same variable x and they have the same exponent, so you have to copy that. And they have the same sign, negative and negative, so you have to add this and you get 9. So copy the sign of their common. So negative 9x. So they have the same variable. What's the variable of 2? That's x to the 0. As what I have explained earlier, provided your x is not 0, x to the 0 is 1. So technically, there's a variable here. So that's 2, and this is negative 1, so they have different sign. So which means you have to subtract. So 2 minus 1, you get 1. Copy the sign of the larger value. So this is larger, so you get plus. Therefore, this is now the answer. That's it. Okay, question. What if we have to subtract this by this? So what we have solved earlier is we add this by this expression. Now this time we have to subtract this by this. So what happened? It's pretty simple. This is actually the subtrahend, so everything else will be changed because you subtract. So in this, our new expression here, so since this is positive, this becomes now negative. This is negative, so this becomes now positive. This is negative, so it becomes positive. And then you go back to the same style, addition. So you have to add this one. So still, it doesn't have x cubed in here, so you'll have to copy that. 3x squared cubed and 2x squared. This is 2x squared. They have different signs, so you have to subtract and you get 0, so therefore you don't have x squared. Now for here, they have the same variable, which is x. Sorry with my ink. So this is x, and this is 5, this is 4. They have different signs, so you have to subtract 5 by 4, you get 1. Follow the sign of the the higher valued coefficient, so you get negative 1x, or you get negative x. And 2 and 1, so they have the same sign, so you have to add 3. So therefore, your resulting expression would be 3x squared minus x plus 3. That's it. Okay, so this time we'll talk about multiplication and division of mathematical expression. So like addition and subtraction, multiplication and division will go hand in hand together, in the sense that division is actually the opposite, or the multiplicative inverse of multiplication. So things that we have to remember when we multiply and divide mathematical expression is that number one is, regardless of the terms, even if they're different, let's say one is x, one is y, you can actually multiply them by putting together. Let's say x and y, so you'll get xy. Number two, when you multiply terms and they have the same variables. Example, um, x squared, um, the other one is x cubed. So they have the same variables regardless of the exponent. You just have to copy the variable. You copy the x and you add the exponent. So example, 3x squared plus times, let's say, 2x cubed. So they have the same variable regardless of the exponent. So you copy the variable x and you add the exponent. So 2, 3, so you get 5. So the next rule is you only have to multiply the coefficient and you'll get 6. So that's 6x to the 5. Another rule that you have to look into is that you have to look into the signs. So if they have the same signs, either positive or negative, the result will always be positive. Otherwise, you'll get negative. Example, 3x and 2x. So 3x squared, 2x cubed. They are both positive, so the result will be positive. If this is negative and this is negative, so you'll still end up with positive because they're both negative. Now, if one is positive and the other one is negative, so you'll end up having a negative value. That's it. Okay, so let's consider this example here. You have an expression 3x minus 2y, and you have another expression as 4x cubed. So when you multiply, rule that I have failed to mention earlier is that you have to distribute. So specifically that one term here is a monomial, the other is not, then you have to distribute the monomial to each of the terms of the polynomial you are going to multiply to. So example, this is a monomial, so you have to distribute these to here and to there. Okay? So let's apply those rules and consider this example. So first we have to multiply that to the first term. So they have the same variable, so again you have to copy the variable, so you get x. And the exponent here is 1, the exponent here is 3, so you have to add exponents and you get 4. And multiply the coefficients, so you get 12. Now next is you distribute these to the second term, so they don't have the same variable, so the rule is you have to copy and write them together. So x cubed and y. For the purpose of the beauty of your equation, when you multiply different variables x and y, you better write x first before y, because in the English alphabet x is written first before y, something like that. So you have to arrange the variable in a way they are written in English. Okay, it's another rule if you have to write a number of variables in a way that they have different and they're written in English but they have different exponents. So it's another thing to say. We can discuss that on the next video. So here is x cubed y. So you multiply 4 and 2, so you get 8. Okay. But they have this different sign. This is negative. This is positive. So negative and positive, you get negative. So that's it. That's it. Okay, now, the previous example we have is that we multiply a term by a monomial. Okay, so the previous example that we have is we multiplied a certain polynomial by a monomial. So which means that monomial is fairly distributed to each term of the polynomial. Now, what if they're both polynomials? So technically, you can select which polynomial you're going to use. Those selected polynomial, you can partition them in such a way that you can treat each term as monomial and you distribute the same method we have used earlier. So example, 3x minus 2y multiplied by the expression x squared plus 2. So let's say I use this polynomial here. So I will partition this in a way that I can treat each term as monomial. So I can use this like x squared. So I have to distribute this in this term. You get 3x minus 2y. And the sign of the next term here is positive, so you get plus here. So 2, and that's again, copy again this, 3x minus 2y. And do the same process. That's all. Okay, so I think I'm running out of ink here, so I'm sorry I haven't noticed. So I shall prepare the next time number of markers. So that's all for now, and thank you so much for watching. So if you have any comments or suggestions, you can comment down there, or if you have question, you can comment down there. So this is actually a video I have made for the reason that there are a lot of people who requested me via text message or messenger to request operations of mathematical expressions. So we're not yet done with the operations of mathematical expressions. So for the next video, I will discuss a method in which we can multiply easily. Like, what if, for example, you have 3x minus 2y multiplied by 3x plus 2y. So something like that. There are certain patterns you have to look into. So I will discuss that next, and thank you so much for watching. Please subscribe now if you haven't subscribed yet for you to be updated. So that's all for now, and bye.